Hello and welcome everyone to the fifth and last workshop of the long-term sustainability series. Today we're going to be working on a way to test your solutions. So we're going to provide you with an actionable plan and some methodology to test everything that you have previously worked on and come up with. And why we want to do this? Okay, everything that we have done, it's important and will bring a lot of insights and valuable information to you, but the real value is brought by testing and by validating things with your potential users. So as soon as you do this, the better. So yeah, we can do this at any time. Remember, okay, we have provided you with five workshops, five modules that you can apply anytime, but they don't necessarily need to be linear. You can do this testing early on after you have drafted your value proposition, and in that way, probably you can optimize your resources and pivot and iterate as early as possible. So now I would like to show you the Canva that we're going to be working on today, and it's this one that you can see here on the screen. Yeah. So it has mainly two sections. So in the first section, the hypothesis definition, we will start by setting the hypothesis. So if you remember the open source Canva, it was divided in 9 sections. What you can see here is a diagram that resembles that and resembles the sections from the open source Canva. And we have divided the open source Canva in 3 main parts. The first one, top left, is the desirability. So this addresses if the users want what we are providing. The top right part is the feasibility. So can we do it? Can we deliver it? And the bottom one is the viability. So what is it worth? Are we going to find a break-even point or not? So let's pick one assumption per each of these 3 sections. It doesn't need to be very elaborate. Let's pick one, and then let's jump to the second stage, which is the creation of the full hypothesis. So for that, you can make use of the hypothesis creator. That is basically the structure that is provided here. It's just guiding you on a way to elaborate a more detailed hypothesis based on this structure. After you have done that, of course, you have already your 3 elaborated hypotheses, and now is the time to choose a way to validate this hypothesis. So to choose an experiment to test them. And for that, we are proposing two tools, or yeah, two ways of moving forward here. One is called the experiment library. This is proposed by Strategizer, and this is like this. It's a description of it's a battery of many different potential experiments that you can run. You have them here in this column, and there are 2 stages. The ones are for the discovery phases. So basically, you want to validate things very early on. You're not sure if you are what's your value proposition, certain things that you are keen on discovering more, exploring, etc. So you have a set of experiments here, and there are the bottom ones, which are called the validation ones. So you have a clear hypothesis that you want to make sure it makes sense, and let's see the rest of the experiment library, how it looks like and what information is providing us. So for example, if you want to do a simple landing page, right? So this is from the type of experiment of call to action. This is estimated qualitatively, of course, as a relatively low cost option experiment with also relatively low setup time and a little bit longer runtime. And the evidence that you can gather with this is okay, not the highest, but okay, relatively low. And then this is applicable mainly to validate the desirability and the viability. Okay. And there are other ones like the crowdfunding, which is more costly. It takes more time to set it up, more time to run it, but also provides a higher level of evidence. And again, this one is also interesting for the desirability and viability phases. So let's imagine that you are deciding to choose for one of the hypotheses to validate it via landing page. We are also providing you with a set of tools to do things quick and with no code. So like form builder, app builders, databases, website builder, for example, the case on the landing page. Organizational tools similar to Notion, but open source, and also automation tools. This is just a selection of potential tools that could be useful for you. Okay, so now let's jump into the second part, which is the field test. Okay, we have created the hypothesis, so we would just need to copy paste the hypothesis here. And we're gonna work in this row. So we're gonna define the experiment, the testing sequence, and analyze what happens after we run this experiment. So for the first hypothesis, we will be also describing here what experiment have we chosen. And then we're gonna be selecting 2 or 3 KPIs to measure and track the impact of that experiment, and also understanding how long is it going to take, right? So we need to also create some time frame and some duration for the experiment to run. And then after we run the experiment, we will just include here our learnings. So we have observed that blah, blah, blah. We have learned from that, we have learned this, and then we are doing that or that thing, right? So this is mainly the structure that we want to follow. And I think, as usual, it makes sense to go through an example and let's see what could have happened for Arduino developers when they were building their project, right? So in terms of the desirability, so this is all selected from the open source Canva that was already filled. So remember that you can either have that or have some parts of it and define some hypothesis for this. So the desirability there's a need for user-friendly and affordable electronics development platform. The feasibility hypothesis is the platform's ability to be used across different disciplines and user skills level. And then the viability one is sustainable growth through community engagement and diversified revenue streams. And now let's go through one of the fully elaborated hypotheses, or let's go through the 3 of them. The first one in yellow is the desirability one. So following this structure, right, we have come up with a more elaborated hypothesis. It doesn't mean that the hypothesis needs to be as long as this one. Whatever idea you have in mind, just put it in words, be concrete for whom you are doing it, what is the value you're bringing, and what do you want to measure and validate, right? So in this case, desirability. Since we have observed that there is a need for accessible and user-friendly platforms for electronics innovation, by offering Arduino as an open source platform with an emphasis on community support and ease of use, we want to appeal to the educational sector and the broader maker community for students, educators, and electronics hobbyists, which should lead to Arduino being adopted as a preferred tool for teaching STEM and personal electronic projects. And the effect will be measured by the number of educational institutions adopting Arduino, the increase in community project submissions, and the volume of Arduino kits sold to educational entities. So now, I would like to not get lost, I would like to go through the field test part connected to this hypothesis. So in this case, we selected an experiment, which was a survey. So a survey to collect direct feedback from educators and students to assess the desirability of an Arduino in an educational context. And the KPIs selected for this were the response rate to the survey, the percentage of respondents who expressed a high interest in using Arduino for educational purposes, and the number of actionable insights gathered to improve Arduino's educational offerings. In terms of the duration of the experiment, it will be 2 months, right? So 1 month for the survey distribution and completion, and 1 month for analysis and report. And then let's imagine that we have already conducted the survey and we are gathering the data and analyzing what happened. So this is again hypothetical, but let's bear with me in this case what we did. We observed that a majority of educators indicated that cost effectiveness and ease of use are their primary factors when selecting educational tools. There was a strong interest in having more structured lesson plans and curriculum integration support. And there is a moderate awareness of Arduino's capabilities beyond basic electronics, such as IoT and robotics applications in the classroom. From that, we learned that a cost-effective educational tool is resonating well with educators. There is an opportunity to increase Arduino's desirability by providing more educational resources and structured curricula. And educators are interested in advanced applications of Arduino, suggesting a potential area for expanding Arduino's educational content. Therefore, and here comes the actions, we will develop and distribute a series of affordable, easy to implement Arduino kits tailored to educational settings together with lessons plans. Launch an online portal specifically for educators with downloadable resources, best practices, and opportunities for professional development. Create a campaign to promote Arduino's advanced applications possibilities. So this is regarding the first hypothesis. Remember, we were drafting 3, so I'm going to read the second one, the feasibility one. So can we do this? I haven't read it yet, so I will read it out loud now for clarity. Since we have observed that DIY hobbyists, scientists, educators, as well as artists and designers require user-friendly tools to engage with electronics and programming, by providing an open source platform that lowers the technology barriers and supports diverse project creation, we want to empower a broad user base to innovate and educate using Arduino. For the inclusive customer segments of educators, students, scientists, hobbyists, artists, and designers, which should lead to Arduino being actively used in a wide array of contexts, from classrooms and labs to studios and workshops. And the effect will be measured by the diversity of projects shared in the community, the breadth of Arduino workshops across different fields, and the uptake of Arduino in educational curricula. So in this case, another example of a potential experiment that could have been chosen is to create a landing page showcasing Arduino's features. And in this case, the KPIs that were chosen were the conversion rate, so the percentage of visitors who express interest through signups or inquiries, the user engagement, time spent on the page, interaction with content, like downloads, views of tutorials, etc., and the feedback quality. So insights gathered from an embedded feedback form on the page. The duration of this experiment is 3.5 months. The landing page being live for 2 months, and then previous to that will be 2 weeks of preparation and then 1 month of collection of the data and analysis. And then the learnings, right? So the test hypothetically has already finalized, and now we are learning what happened out of it. So there was a high rate of signups for more information, especially from educators and DIY hobbyists. The tutorial video embedded on the landing page was the most interactive with element, suggesting a high interest in learning. Users spent time on sections of the page that outline beginner-friendly project samples and educational applications. From that, we learned that there is a strong interest in Arduino products that are perceived as accessible and beginner-friendly. Visual learning aids are appreciated, and users are looking for immediate ideas and inspiration for using the product in a wide range of practical applications. Therefore, we will develop a new user onboarding experience that includes more visual learning tools and easy-to-start projects from different fields, produce additional video content that guides new users through their first project from unboxing to completion, and then finally, highlight practical applications of Arduino on the main website and in marketing materials to capture the interest demonstrated in the landing page analytics. So that was it regarding the second hypothesis and the landing page. And now let's go to the last one. Here, we want to validate the viability hypothesis. So let me read it out loud for you. Since we have observed the need for sustainable revenue streams to support the ongoing development and community engagement of an open source electronic platform, by leveraging adoption criteria such as community growth contributions, educational penetration, etc., and hardware sales, certification programs, and educational content, we want to create a self-sustaining business model that allows for continuous innovation and community support for the global open source electronics community, including DIY enthusiasts, educators, students, and professional developers, which should lead to increased brand loyalty, community contributions, and adoption in educational settings. And the effect will be measured by the rate of community growth, the volume and quality of community contributions, the number of educational institutions adopting Arduino, the diversity of projects utilizing Arduino, and overall brand recognition in the maker and educational markets, as well as by hardware sales revenue, number of certification issues, licensed manufacturing partnerships established, and educational content sales. So here we chose a crowdfunding campaign. This is a pretty good example that would we are pretty familiar with. And the KPIs chosen are 3: total funds raised compared to the campaign goal, the number of backers on average pledge amount, the number of educational institutions and teachers participating. I said 3, it's 4. Post-campaign surveys to measure backers' intentions to use the board in educational or project settings. The duration of this experiment is a little bit longer. It could be even longer, but in this case it was 4 months. The campaign was active for 2 months, and then 1 month for preparation, 1 month for campaign analysis and surveys. And now let's imagine this has finished, and we are going to the learning phase and understanding if this was a success or not. We observed that the campaign reached its funding goal within the first few weeks, with a significant number of backers being educators and institutions. Backer engagement was highest with updates that included projects, ideas, and educational applications. Post-campaign surveys indicated a strong interest in using Arduino for classroom learning and independent projects. From that, we learned that strong market demand for products aimed at educators and makers. Educational content and project ideas are key factors driving interest and backing for the product. And crowdfunding can be an effective way to gain market interest and fund new Arduino product developments. Therefore, we will focus on developing additional educational materials and product kits to accompany the Arduino board. Consider using crowdfunding for future product launches to validate market interest and secure initial funding. And the last one, engage with the backer community for feedback and collaboration on the development of educational programs and project ideas. And with this, we have already provided you with some insights of how Arduino could have done this if using this framework. I would just like to finalize with this sentence. Everything that doesn't lead to validated learning is waste. And this is inspired by the creators of the Lean or the Lean methodology, which are Toyota and their material waste. So I hope that you agree with that and you try to validate everything that you are coming up with. And that I hope as well that this workshop and the series of the workshops were of value for you and that you can make the most out of them. Thank you very much. Stay in touch and good luck. Bye-bye.